Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called insert into a sorted circular linked list. So we were given a circular linked list node, which is sorted in non-descending order. Write a function to insert a value, insert value, to the list such that it remains a sorted circular list. The given node can be a reference to any single node in the list and may not necessarily be the smallest value in the circular list. Okay, and if there are multiple suitable places for insertion, you may choose any place to insert the new value. After the insertion, the circular list should remain sorted. And if the list is empty, you should create a new node and return the reference to a single node. Otherwise, you should return originally given node. Okay, so this was pretty complex in description, but it was actually pretty straightforward. So we were given a linked list, which is a circular linked list, meaning its tail is pointing to the head. And we were given the head of the circular linked list, okay? And it is sorted in non-decreasing order. So we can see here we have 1, 3, 4. If you view from 1, okay. And here we still have a 1, 2, 3, 4, which is sorted in non-decreasing order. And we were given the head here at 3. So for this, we are going to insert 2 for this, okay? So we walk from 3 into 4, and this is not the right place to put, and we go to 1. This may be the place to put because the insert value is larger than 1, okay? So it can be put behind 1. But we still have to check whether the next value is smaller than that. But since it prompts us after the insertion, this should remain sorted. Where is that? Given node can be a reference to any single node in the list, may not necessarily be the smallest value in the circular list. So basically, if we are going to add 2 here, that's the only way we can do this, okay? But if we are going to add something like, let's say if we have a 2.5 here, we can still add 2 here, okay? So it doesn't really matter. So we have to know what's next. And we also have to know the previous node in order to make the link to the new node, okay? So there are several possible scenarios to think about. So the first, as prompted in the problem, we're given a null list. So in this case, we're going to create a new node with the value and return it, okay? And second one, if we were given a normal sorted list, like in this one, 2, 3, 4, 5, and the insert value is in the middle, let's say 3.5. So this should be pretty easy. We need to record a previous node and we need to record a current node, and we just insert the node to between previous and current, okay? So 3.5, we should add it between 3 and 4, where 3 is the previous node and 4 is the current node, okay? And there's another possibility, like we still have 2, 3, okay, 3, 3. I think it works too because it says in non-decreasing order, not ascending order, okay? So if the insert value is 6, meaning we are at the middle of this, okay? So that will result in something like here, okay? So that will result in a problem that previous node's value is larger than current value, okay? So in this case, prev dot value is larger than per dot value, okay? So if our insert value is less than or equal to let's see, if it's larger than or equal to, right? Larger than or equal to previous dot value, or insert value is less than or equal to current dot value, okay? I may have made a mistake here. Okay. Yeah, let's see if there are any other scenarios. So first we're given a null, okay? We're given a normal list. We put it in the middle, okay? We put in the and. Okay, we covered that. And is there anything else? Oh yes, there is another scenario where all the nodes were the same. So in this case, I think it doesn't really matter where we put it. We can just put it somewhere in this linked list and return it. Okay, so that should give us the right answer. Let's code it out. So first thing is to take care of the null list. So if head equals to null, we are going to insert a new list node, like new head, which is to new node insert value, and we are going to return it. But before we do, link it to itself. Because we are having a circular linked list. So new head dot next equals to new head. Okay, and return new head. Okay, so that's the first scenario. So after that, we can deal with the normal situation, okay? Normal scenario. We, as I said, we need to have a previous node, which is pointing to head. And we're going to have a current node, which will be pointing to head.next, okay? So they move together, okay? And we can use a flag, like a boolean, to indicate where is the right place to insert, okay? To insert, it was initially set to false. So we will do this while what? While previous is not head. Okay, so while we were traveling through this circular list, we don't want to go on and on. We will go loop through it for just once. Okay, so that's why we have while previous is not head again. Okay, so what do we do here? First, normal situation. Okay, insert in the middle of the list. Okay, so if previous dot value is less than or equal to insert value, and insert value is less than or equal to current dot value, so that's the right place. So previous dot next. Okay, we don't have to do it now. We can just set the flag to true. Okay. Else, if it's not like that, we're inserting it to the tail of the list. So okay, so here we experience insert value is larger than or equal to previous dot value, or when insert value is less than or equal to current dot value. Okay, we also set to insert to true. Okay, all right, yeah, that's to find the right place to insert the value. So now what do? We just put it into the right position. Okay, so if to insert, we're going to insert it. Okay, so prev.next equals to new node insert value, and we're going to set the next node to cur. Okay, so it has a next. Oh, actually it supports a next value, so we can just put the cur here. Okay, and next we're going to return, what do we return? We'll still return the head. Okay, and if we found the right position, what do? We can just keep it going, okay, until it reaches the end of the list. Okay, so we will keep it going. So previous equals to cur equals to cur.next. Okay, so that should take us to the end of this circular list. And there's another corner case. All the same value. So for here, we can just insert value cur. We can just insert it anywhere. Okay, and return head. Okay, so that should give us the right answer. Let's see. Oh, it gives us the wrong answer. Oh, okay, here. The problem's here. So before we do anything to determine whether the node should exist here, between the largest tail and the smallest head, we have to know that we are here. Okay, so that is to say previous dot value is larger than cur dot value. Okay, yeah, that's one mistake I made. Okay, yeah, I think that gives us the right answer. So for time complexity, it should be ON because we are traversing through the circular linked list. And for space complexity, we have O1 because we're not using any other extra spaces. Okay. All right, it passes. And thank you so much for watching. I'll see you in our next video.